This is Miss Lee again, and we're continuing our making sense of fractions, decimals, and percent, the FDP benchmarks. This is part 2. Okay, so let's take a look at the tenths. Our dollar bill has been cut into 10 equal pieces, and I'm going to shade one of them. The fraction that this represents is 1/10. And we talked about this in the first video, that 10 dimes equal one whole dollar. So each part, because they're 10 section, each one gets a dime. So 1/10 equals a dime, and a dime is 10 cents. So as a decimal, you can write 1/10, or if you want to put it in money format, 10 cents. And of course, this is going to be 10 cents out of 100 cents. So the percent is 10%. So as you add another tenth, what you're doing is you're adding another dime each time, or another 10 cents. So if you have two of them shaded, it would be 2/10, which is 20 cents, 20%. Okay. Then you have 3/10, which is 3 dimes, which would be 30 cents and 30%. Add another 10 cents to make 4/10, 40 cents, 40%. 5/10, which is 5 dimes, 50 cents, and 50%. 6/10 is 6 dimes for 60 cents, or 60%. 7/10 would be 70 cents, 70%. 8/10 would be 80 cents, or 80%. 9/10 would be 90 cents, and 90% would be the equivalent percent. And then if you add the 10th one, you have one whole dollar. So the tenths go by 10 cents. So you write as 10 cents, or you can write it as 1/10, and the percent is 10%. That one's pretty easy. It just goes by tens. And now we have the thirds. The thirds is different. There are no 3 coins that would add up to one whole dollar. If you take a dollar and you divide it by 3, let's see what happens. 3 doesn't go into 1, but it goes into 10 3 times. 3 times 3 is 9, subtract 1 remainder. Bring down this 0, we have another 10. It goes in 3 times, which is 9, subtract 1 remainder. We can add another 0, bring it down. We have another 10. 3 goes in 3 times, which is 9, subtract 1 remainder. So you can see what's going to happen. The 3's keep repeating. This will never end. We will never have a 0 remainder. We will always have a remainder of 1, and this 3 will keep repeating on and on and on and on. Okay, that's what makes the third special. So this is 1/3. And the way we write the decimal is going to be 33 hundredths repeating. And we put this bar above the 3, and what that means is the 3 goes on and on and on and on. It never ends. So 1/3 as a decimal is 0.33333333333, and keeps going on and on and on. Okay, but of course we're not going to write all those 3's. We just put the repeat bar above the 3. Then the percent, there's 2 different ways you can show it. One way is to say 33.3 repeating percent. Now, some students do this. That's not the same. The whole number cannot repeat. The ones place does not repeat. What repeats is that every decimal value is a 3. That's what's repeating. So we're not writing it this way. You have to write 33.3 with the repeat bar above it. Or you can write it as 33 1/3%, where this 1/3 represents the repeating 3's. Okay, you need to be familiar with both formats. Now, what happens if we go ahead and shade a second part? Well, our fraction is now 2/3. Go back and look at 1/3. This is a quick little way of remembering. 1/3 means threes. The threes are repeating. If you have 2/3, that means you want to double it. So instead of repeating threes, if you double 3, you get 6. So 2/3 would be repeating 6s. And then the percent would be 66 and 6/10 repeating percent, or 66 and 2/3%. And then if you were to shade all 3 sections, it would be 1 whole. So this is the thirds. This is something money really isn't going to help you out with. You're just going to have to memorize it and know it. So let's do some practice. If you need to look at the notes we just completed, you can, but I suggest let's try it first without looking at the notes. Okay, we want to identify the fraction, decimal, and percent amount that's shaded in the model. So fraction, decimal, and the percent. Okay, this is a 10 by 10 grid, so there's 100 squares. We've got 3 rows shaded. There's 10 in a row, so that means that there are 30 shaded. So there's a couple of different ways you could write this as a fraction. You could write it as 30 out of 100 if you were counting the individual squares, or you could do 3 rows shaded out of 10. These are actually equivalent. You can simplify this fraction and you would get 3/10. Okay, now I want to write it in decimal format. 3/10. You could say, oh, 3/10, let me write it just as it sounds, where 3 is in the tenths place. Or the denominator is a 10. Think of dimes. 3 dimes is 30 cents. And then think of your percent. We had 30 shaded out of 100. 30 is out of 100, so it's 30%. And our last example, in the last inning of the game, Ethan threw 12 strikes out of 18 pitches. Determine if each statement is true or false. Before I even look at the statements, just glancing at them, I can tell that I've got a percent, I've got fractions, another percent, a decimal. So I know I'm going to need to figure out a fraction, decimal, percent equivalent for his pitches. Okay, I'm not given any kind of decimal or any kind of percent values in the problem itself. What I'm giving is that he has 12 strikes out of 18 pitches. That's a fraction. 12 out of 18. Now looking at this, I know that there is no coin where 18 would make 1 whole dollar. So I'm going to simplify this fraction. I'm going to divide it. And I'm going to divide it by 6. Common factor for 12 and 18 is 6. 12 divided by 6 is 2. 18 divided by 6 is 3. 2/3. This is a benchmark fraction. We just got done talking about 2/3 and 1/3. We know that 1/3, 1/3 is repeating threes. So 2/3 would be double this amount. Double the threes and you get repeating sixes. Alright, so now that we know this, let's go ahead and go through our statements and determine what is true and what is false. A, of the pitches Ethan threw, 66 and 2/3% were strikes. Alright, we know the decimal is repeating, 66 hundredths repeating. What is the percent for 2/3? Is it 66 and 2/3%? It is. This is one way of writing the percent. The other way is to write it 66 and 6/10 repeating percent. So A is a true statement. Ethan's number of strikes to total pitches is 4/9. So strikes to total. That's what we're showing here, strikes to total. Okay. My strikes to total was 12 to 18. So what do I need to multiply 4 by to make it equivalent of 12? I can multiply it by 3. We're making an equivalent fraction, so I have to do the same thing to the 9, and 9 times 3 does not equal 18. So this is a false statement. Ethan did not pitch strikes 30% of the time. Okay, we know he pitched strikes 2/3. So he did not pitch strikes the remaining third, which is 1/3. Is that equal to 30%? No, because that 3 is repeating. It's equal to 33.3 repeating percent, or 33 1/3. So this 30% is wrong. This is a false statement. Ethan threw a strike 66/100 repeating of the time. And that's true because 2/3 is the repeating sixes. So that statement is true. Okay, now you're ready for your independent practice.